that'll help us answer this question. F of x is the natural log of x, which is this red graph right here. Y equals 2, horizontal blue line, x equals 1. And the purple line, y equals -2, is the axis of revolution. And here's the integral right here. The question is, where did that come from? We're going to use the idea that we can use the washer method. So if y equals -2 is the axis of revolution, we want pi times the integral from 1 to e squared. Now, how did I get e squared? Well, I know that when y equals the log of x intersects the line y equals 2, I'll put a 2 here and convert this to exponential form. E to the second power produces the x value. So that's how we got e squared for the x coordinate. Anyway, the outer radius is the distance from the axis of revolution to the farthest point in the region that we're revolving around the axis of revolution. And that's going to be a constant, actually, because the distance from 2 to -2, think of it as 2 minus and -2, the distance between 2 points on a number line. It's the difference between them. It really doesn't matter the order that you subtract in, because we're going to square the result anyway, outer radius squared. But 2 plus 2 is 4. 4 squared is 16. So there's the outer radius squared right there. Now the inner radius is this distance right here for a typical rectangle. And the y coordinate of this point is f of x, or the log of x. Whatever the x coordinate is as we integrate along this interval from 0 to e squared. The y coordinate is the log of x. That's this distance right here. But I need another plus 2. Think of it as top minus bottom minus a -2, or the log of x plus 2. I left it as f of x, but there's the inner radius squared. You didn't have to evaluate the integral, but it looks like it's 95 point something. We could get an exact value with pi in the answer. But for now, we'll just leave it like that. Setting up the integral looks something like that. Okay, hope that helps.